What is predictive maintenance? Predictive maintenance is the most technologically advanced element in a maintenance program. It utilizes microprocessor-based technology to evaluate the condition of operating equipment. Aggregates industry PDM services are comprised primarily of vibration analysis and infrared thermography. Infrared thermography is a non-contact testing procedure that uses an infrared camera to measure the temperature of items to determine if there are heat-related problems. Vibration analysis is primarily used to monitor the condition of rotating equipment. It can detect bearing and gear faults, drivetrain misalignment and other mechanical fixture problems that lead to premature failures. This makes it possible to detect specific faults such as inner or outer race spalling, cage faults, ball or roller damage in bearings and excessive wear in gears. Several different types of bearing faults identified using vibration analysis are shown as examples of bearing and gearbox issues identified during periodic testing. It should be noted that not all faults require immediate action. However, once a bearing or gear fault occurs, it will only get worse. Bearings never heal themselves, so it is always a good idea to make certain that spare parts are on hand and that continued testing is scheduled to monitor the rate of deterioration to avoid catastrophic failures and extraordinary repair costs. Vibrating screen bearings typically rotate at a speed of up to 1000 cycles per minute and can produce forces in excess of 5 Gs. Screen bearing data is obtained by filtering out the lower frequency vibration caused by the motion of the screen, leaving only the higher frequency data of the bearings and/or gears. The following examples represent the filtered data from screen bearings. Note the difference in amplitudes of the two spectra. The bad spectrum has amplitudes 7 times higher than the good spectrum. The vibration signature can provide important information about the mechanical condition of bearings, gears, compressors, pumps and fans. Faults such as imbalance, misalignment, coupling faults and structural looseness can create excessive radial and axial loads on bearings, causing premature bearing failure. Vibration analysis can be used to detect these faults and allow for timely corrective action. Operating analysis on vibrating screens is capable of providing data that can assess the efficiency and structural integrity of screens by analyzing their rotating motion. This type of data is collected on all 4 corners of a screen or feeder and is used to determine the rotational characteristics of the vibrating unit. 2 transducers are placed on each screen support spring to collect data in the vertical and horizontal planes simultaneously. When the 2 signals are collected, and plotted against each other, an orbit plot results. The orbit plot represents the exact elliptical motion of the screen. The vibration data collected to produce the orbit plot also contains a great deal of information regarding the physical motion of a screen as shown at right. Problems such as weak or broken springs, cracked or broken deck frames and structural support problems can be identified using this method. Thermography is a non-contact testing procedure that uses an infrared camera to measure the temperature of items to determine if there are any heat-related problems. Typical electrical applications include scanning motor control centers, control wiring and overhead power lines for loose connections, dirty connections and overloaded phases. The poor connections and overloaded circuits generate excessive heat that is visually indicated with the infrared camera. These faults are not visible with the naked eye and are difficult to find without specialized equipment. Operating deflection shape, ODS, is a testing procedure designed to measure and graphically represent the relative deformation of a machine or structure under normal operating condition. The human hearing ranges from 20 to 20,000 Hz. Sounds above that range are known as ultrasonic. Most all sources of friction have an ultrasonic component in their sound signature. Ultrasonic guns convert ultrasonic noise to sounds that humans can hear. Changes in the pattern or amplitude alert us to mechanical changes that can be signs of impending failure, allowing an opportunity for timely corrective action. For more topics and more detail from us, visit our websites at quarryvision.com. and QuiTraining.com.